We're working on an origami-based, deployable ballistic barrier that will keep emergency personnel safe during a hostile situation.
We met with federal agents that often use current shields and asked what could help them to better do their job.
Current products out there are about 90 pounds. That's pretty heavy for one person to carry, and it only protects one person. Our goal was to go for 50 pounds and protect 2 to 3 people.
This pattern is a Yoshimura crease pattern, and when it deploys, it provides these nice angles which we hope will be even more effective shape for a barrier. So going from paper to other materials can be really challenging.
It has 12 layers of Kevlar with an aluminum core in the middle. The students did a lot of calculations, and 12 layers is really what you need to be able to withstand a bullet from a handgun. One of the great things about this particular fold pattern is that it opens and closes really easily. In an emergency situation, you've got to be able to just get that thing open and get it in the way.
Today's objective was to see if it worked, if it actually stops bullets.
My first thought was, did he miss? So I went back to the high-speed camera that I'd been filming, and the bullet sunk right in.
Range is hot. It was exciting to see that it did stop the bullets, and we were able to successfully demonstrate it with 9mm, 357 Magnum, and 44 Magnum pistols.
The federal agents that saw our initial prototype were really excited about it.
Their response was that this is a revolutionary product.
My dad is actually a police officer himself. This could be something that could be used by him or other officers that could prevent injury or even save their lives.
it's a disaster or some sort of crisis where communication is key, a tech company has come up with a device that clips into your teeth, and it makes it much easier to understand what's being said. It is called a molar mic. Firefighters and other first responders have been trying it out. The Department of Defense is going to work on developing the technology to eventually outfit the Air Force and possibly other military branches. Okay, so you heard it a little bit. Let's talk about how it works. A miniature version of a traditional headset clips into the back of your teeth. There's a tiny microphone and a speaker all in a custom-fit mouthpiece, and it blocks out external noises. It leverages your teeth and jawbone to create a new auditory path for hearing as well, so you don't need an earpiece. Some California firefighters did try it out to compare it to their regular two-way radios. Look at the difference.
Okay, the saw and the electric saw and the blower are on now. Okay, the blower is going. We have
That is night and day. Do you see that right there? Oh my goodness. The molar mic can be used underwater, and it can also be used with full face masks as well. The Air National Guard did try this out during Hurricane Harvey. Pararescue workers say they could hear clearly during those extreme conditions. Now, we don't know if the military or other first responders are going to be testing this or using it during Hurricane Florence.
I mean, I have seen lots of butterflies, but they're mostly colorful. So I have never seen any butterfly which is transparent, right? Initially, in fact, I didn't notice it, but my wife noticed it, and she said that there's something there. But when it sits on the leaf, then you can really notice it, oh, there's something.
I am a graduate student in Professor Chu's lab, and for the past 3 years or so, I've been working on a very small scale, micro scale implant that goes inside your eye to monitor pressure real time to better enable glaucoma therapy.
To make this approach more practical, we have to make sure that the sensor becomes angle independent, which means we can shine the light at any angles into the sensor in the eyes and then collect the signal back from this sensor. Okay? But this is a very challenging task. This is something that is very difficult to overcome.
The interesting thing about the glassing butterfly, it's literally transparent. So when you see into the scales, you will see tiny billions of nanostructures 50 times thinner than your hair, which makes the light transmit through it. And the same nanostructures give them this transparency. Also can kill any bacterial cell which can grow on top of it so that it don't get any bacterial infection, for example. This is perfect match. Exactly what we need for our biomedical applications. We have to understand them, why this nanostructure is creating all these fancy optical properties, right? So we put it under scanning electron microscope. We study the nanostructural pattern on the wing. Then we brought this glass wing sample into our optics lab here in our Chu lab. So we do all sorts of angular, optical properties, characterizations, and try to understand how it behaves then. So once we understood how the structure works, then we fabricate those nanostructures in the clean room facilities in KNI. It's Kavli Nanoscience Institute at Still.
We used phase separation technique. We combined two different polymers and we spin them at a very high frequency on a flat substrate. So we're able to create a matrix of one polymer, which is perfectly flat, and little ellipsoidal pillars of the second polymer to mimic the size and the spacing of the structures that were found on the butterfly wing. And we leverage a wetting technique that makes silicon nitride even more hydrophilic. We had 50 to 60% reduction in adhesion of cells and essentially achieved a different sort of anti-biofouling surfaces suitable for our application.
So once we have it done in the clean room, we bring it here in our optics lab. We characterize the sensor for optical pressure sensing. And then once we are confident about the performance of the sensor, then we took the sensor to UCSF for implant.
So what we have accomplished with the micro and nanotechnology inspired by these butterfly biophotonic structures is a sensor that can be used in everyday life. We envision that this sensor can be used by these glaucoma patients on a daily basis, possibly combined with their smartphones to improve disease management, the treatment, and reduce these blindness that's caused by the glaucoma.